parabolas. We've done circles and ellipses. Now we're going to do parabolas. First of all, let's talk about what is a parabola. Well, it's the set of all points that are equally distant from a point called the focus and a line called the directrix. Well, what does that mean? Well, let's draw it and see what that looks like. So if I have let's make sure you can see this. If I have a point called the focus and a line called the directrix, we'll just put these in space here. A parabola is the shape that is made when you, watch this, okay, that is made from the points that are equally distant from the focus and the directrix. Now, I probably haven't made this as good as I should, so if I made this better parabola, then this would look better. See how those lines are more correct? Okay, so this line is the same size as that line because they are equally distant from the directrix and the focus. Now watch this. If I take a line up here and I draw it down to the directrix and then I draw it to the focus, those lines are going to be exactly the same size. And that's going to be true anywhere that on this parabola. So a parabola is the set of all these points equally distant from the focus and the directrix. That's what a parabola is. So let's draw this parabola in a little bit better. This is an upward facing parabola. Okay. The axis of symmetry cuts it in half. That's exactly as you would expect and have learned in the past. If I have an axis of symmetry, it's going to cut the parabola in half. That is my axis of symmetry. And let's label, this is the directrix, and this is the focus. Where is right here is my vertex. This is going to be important in a moment. Okay, we have a special letter when we're using parabolas. If you remember, this is P. P is the distance from the directrix to the vertex and from the vertex to the focus. Let me draw it. Vertex to the focus. So P is this distance from the vertex to the directrix. It's the same distance from the focus to the vertex. That is also P. Now, a term you have not heard before, I think, is called latus rectum. Not a body part. This is the segment, the line segment, through the focus, ignore my spelling, parallel to the directrix, with endpoints on the parabola. With endpoints on the parabola. Now that sounds like a lot. Let me just draw it. So the latus rectum is parallel to this directrix, goes through the focus and ends up and has endpoints on the parabola. So this right here, endpoints on the parabola going through the focus, let me draw a line. This is called the latus rectum. Okay, that's that line. Okay, so that's a parabola. Now let's review the standard form equation. So here we have, if we have x squared, remember a parabola, only one of the variables is squared. If x is squared, then this is an up and down parabola. This right here is an example. This is a vertical parabola. If y is squared, then we have a horizontal parabola. So if we have x squared and p is greater than 0, Then we have the parabola faces up. P is less than 0, the parabola faces down. We have a vertex at HK. You see our H and K. Our focus. Now, let's look at this picture. In this picture right here, looking at problem number 1, our vertex is right here at -4, +3. Okay? That's our vertex. So we'll label that right here, vertex as -4, +3. And what is that? Those are H and K. My focus is always going to be inside the parabola, so it's going to be somewhere, it's going to be H, -4, and then it's going to be K, 3, plus P. So, no, let's not put -4, sorry about that. Let's say H and K plus P, okay? So you go over H and then you go K, 3 plus P. My directrix is going to be, remember we said the directrix was equally distant, P a distance away from the vertex. So if this, let's label this focus. The focus is at -4, and this is at 5, -4, 5. So what is P? Let's label this, that's really important. P equals 2. So if P is 2, where is my directrix? Well, it's 2 down from the vertex. So P is going to be here at 1. I didn't draw it very straight. It's going to be Y equals 1. It is 2 away from the vertex. So it's this whole line here. Do we see that? Okay. So the directrix is going to be Y equals K minus P. The axis of symmetry is going to cut right through this parabola, and it's just going to be X equals H. It's really much simpler to draw these things than to label them, but for math reasons, I guess we should. All right, so let's look at the standard form of the equation. If I have a parabola right here, how do I get the equation? Well, I have H and I have K, and I now have P equals 2. So I have everything I need with H, K, and P to write my standard form equation. I know that it's a vertical parabola, so it's X minus H plus, so it's -4 plus 4 squared equals 4 times P is 2, times Y minus K, Y minus 3. So let's rewrite that one more time. X plus 4 squared equals 8 times Y minus 3. This is the standard form of the parabola shown above. Okay, so I'm going to do one more with you and then you can do the last one. So looking at the second parabola, what do we know about it? Well, for one thing, it's going to be a horizontal parabola. So Y is going to be squared. We know that Y is going to be squared. We know that P is greater than 0. We know that the vertex, we can tell that the vertex is where? The vertex is at -3, -2, -3, -2. Aha, so what do we have? We have 2 of our 3 letters. We have H and we have K. We have a
Tina, can you come to the main office?
directrix.
Thank you.
This line right here is the directrix. The directrix is at X equals -6. So if I have a vertex at -3, -2, how far is it from the vertex to the directrix? This P is P equals 3. Therefore, how far is it to the focus? Well, that would be the same, 3. So my focus is at 0, -2. This is the focus because it's got to be the same distance away from the vertex. Okay, so I know that p equals 3. So did you hopefully saw where I got that? Now let's write the standard form of the equation. So I look up at my horizontal equation, y minus k squared equals 4p times x minus h. So let's just fill in the numbers. So y minus k minus a negative plus 2, the y is squared, equals 4 times p times x minus h squared. Not squared. Only one is squared. So let's write that one more time. Y plus 2 squared equals 12 times x plus 3. Okay, I want you to do the last one. Bring it to class and we'll see how you do. Standard form equation of the parabola shown. Now on your sheet, make sure the focus is not drawn, so make sure you have the focus labeled at 5, negative 3. Okay, there you go. Okay, all right, let's turn it over. Now, just to make sure we don't have any problems and you can see it, we're going to, just like we did with the other equations, we're going to rewrite these equations into vertex form and state all the properties. So what did I do? What did we do last time? We got all the x terms together. We know that standard form says x squared minus 6x equals, we're going to put the y terms on the other side now because we're going to put all of the y terms on the other side, equals, and if I move the y term over, I have to add 4y to both sides, equals 4y, subtract 29, so minus 29. So I've got my x terms on one side, my y terms on the other side. So the first thing I want to do is complete the square. I remember how to complete the square. That would be negative 6, take the b term, half it, equals negative 3 squared, and that's going to be positive 9. So I'm going to take that 9 and put it right here. I'm going to complete the square. If I add it to the left, I also add it to the right. So my complete the square form is x plus this term, x minus 3 squared, equals, what do I have left? Well, I have 4y, negative 29 plus 9 is minus 20. Now, what can we're still not complete yet. We need to have a y minus k. So what can I factor out of 4y negative 20? Well, that would be 4. So let's write this over again. X minus 3 squared equals 4 times y, take the 4 out, minus 5. And now I have the standard form. So looking at this equation, I can get all of this information. First of all, what is p? Well, we know that the standard form of the equation, I'm going to put it right underneath here, is x minus h squared equals 4p times y minus k. All right, so to find p, we say, okay, well, we know that 4p equals 4. What is p? Well, divide both sides by 4, and you get p equals 1. P is 1. See how I did that? I know that 4p equals 4. These two set these equal to each other, and I can solve p as 1. Okay, what is my vertex? My vertex is hk. X minus h, y minus k, 3, 5. What is my focus? The best way to figure out the focus is to actually draw it. So if I draw a parabola, my vertex is at 1, 2, 3, 1, 2, 3, 4, 5. 3, 5. That's my vertex. I know the parabola is opening upward, so it's a parabola opening upward. I know that p is 1, so I'm going to have a focus 1 inside my parabola. So if the vertex was 3, 5, what is my focus going to be? Well, my focus is going to be 3, 6. Okay? So my focus is 3, 6, and what is my directrix going to be? Well, it's going to be the line 1 away, the same distance away. 1, 2, 3, 4, the same distance away. So my directrix is going to be y equals 4. It's a parabola opening upward. Okay? I hope we saw that. I'd like you to do the next one. Bring that into class tomorrow. All right, let's do 2 of these from example 3. Write the equation of a parabola from the description. Always, 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 what am I going to tell you? You know I'm going to tell you to draw it. So let's draw it. So we have a vertex at, let's draw this. Draw your coordinate plane there. I'm going to move this up a little bit. Okay. Draw your vertex at 2, 5. 1, 2, 3, 4, 5. Vertex. Draw the focus. That's my vertex. My focus is this way. 4, 3, 4, 5. So this is my focus. I have learned a lot just by drawing those 2 points. What do I know? Well, I know that I must have a parabola that opens to the right. If I have a parabola that opens to the right, what do I know? Well, I know that y is squared, and because it opens to the right, p is greater than 0. Looking at this drawing, I know p. I know that p equals positive 2. It's opening to the right, so p must be positive. I have the vertex. I have h and k. So I have everything I need. If I have h, k, and p, I have everything I need to write the equation. So we're going to write the equation. We know this is a y squared, so we start with y minus k. Y minus 5 squared equals 4 times p times x minus h, 2. Now we just have to multiply those together. Y minus 5 squared equals 8 times x minus 2. All right, and there you have it, the standard form of a parabola opening to the right. Now let's do C. I want you to do B by yourself and then bring it into class. Here we go. We know that the graph opens down. If a graph opens down, I immediately know 2 things. X is squared, P is less than 0. There, I know those 2 things. A vertex at 4, negative 2, I know H, I know K. And a lattice rectum has a length of 40. Okay, well, let's draw this and see what we can tell from that. So, we're going to vertex at 4, negative 2. So, always draw. Okay. We're going to say, we know this parabola opens down, so 1, 2, 3, 4, negative 2. We have vertex at 4, negative 2. It opens downward. It's going to be a pretty wide parabola. So let's draw it pretty wide. Now what we know is that the focus at some point is here. And the lattice rectum is the line that goes through and if its total length is 40, then the distance here is 20 and 20. Okay? So one thing I'll tell you about the lattice rectum is that 4p is equal to that total length. So that is actually something new that we're learning about the lattice rectum. 4p is equal to that total length. So now I can solve for p equals 10. What else do we know about p? P is negative. Okay, so new fact. Sorry, I'm introducing a new fact. A new fact. 4p equals LR. Okay. So p equals -10. So now I have a vertex at 4, -2. What do I have h and k, so I have everything I need to write the standard form of the equation. This is a parabola opening downward. So we have x, the x is squared, x minus 4 squared equals 4 times -10 times, sorry, I'm going to write this next to it, times y minus a -2. So minus a negative becomes positive. Let's write that again. X minus 4